can see that. I can't see anybody. So Larry, can you just let me know? Is that okay?
Perfect.
Brilliant. So yeah, welcome everybody to this ASBP Reusing Timber in Construction webinar. We've got 4 really fantastic presentations to look forward to, and then we'll have a bit of Q&A afterwards. Just a quick couple of intro slides. My name's Debbie Ward. I'm a director at the ASBP, and I lead on the Reuse Now campaign, which is supported by a number of different sponsors. Cleveland Steel and Tubes are our gold sponsor and long-standing patron member, and then we have Optima as a silver sponsor, with EME, Reusefully, Circuland and Woodknowledge Wales as our bronze sponsors, and it's great for their support to enable us to do the work that we're doing. So today I'm just going to give a brief introduction of the ASBP, and then we'll move on to the presentations. We've got Charlie from TD UK, Phil Isaac from Simple Works, Danielle Bianchi from Cullinan's, and Diana Waldron from Woodknowledge Wales. As I say, all giving some very interesting presentations around case studies of different work and projects that they're involved with, and Charlie kicking off with a bit of an overview as to where we are with timber reuse in the industry. So the ASBP, many of you on the call on the webinar this lunchtime will be aware of who we are, but just as a quick recap, we're a not-for-profit mission-led sustainability organisation with a mission to accelerate the transformation to a healthy, low-carbon built environment by championing the use of demonstrably sustainable building products. We work across lots of different areas, including resource efficiency and circular economy, of which obviously reuse is part. We also do a lot of work around health and well-being, things like indoor air quality, damp and mould, and whole life carbon, which obviously dovetails very much into the resource efficiency side. And then also looking at ethics and transparency, technical performance, and social value. So the Reuse Now campaign has been going for a couple of years now. As it says on the tin, we encourage greater reuse of building materials within the construction industry, doing this through different events such as webinars and in-person events, blogs, case studies and other reports. Just recently done a deep dive on the reuse of glass partitioning systems, and we're looking at doors also at the moment, so lots of different activities. And we've got events upcoming after the summer. One particular date, the 16th of October, you can put in your diary. The venue is at I/T in London. We're just formulating the agenda there, but we've also potentially got webinars on the reuse of concrete and a policy and standards update. Lots of information on the ASBP website. I'd really encourage you to have a look on there and potentially consider becoming a member. Larry can just put the links to the ASBP website in the chat so you can have a look at that. And just a bit of housekeeping. Throughout the webinar, you can add questions to the Q&A, please, not into the chat. You can upvote and comment on other people's questions. Please don't use the raise hand option. We can unmute the audio of the relevant attendee that's asked the question to ask it verbally, or if we're short on time, we'll ask the question on your behalf. If you have any technical problems, if you can just drop a note in the chat to Larry and he can help you. As you've probably already noticed, we are recording the webinar. If you prefer your audio not to be recorded or don't have a mic but would like to ask a question, please tick send anonymously when adding a question to the Q&A, and I'll ask it for you on your behalf. So without further ado, I shall pass on to Charlie, who's going to give us an overview of current timber reuse.
Debbie. Okay, hopefully you can see my screen now. It's all good. Okay, yeah, so Charlie Law, Sustainability Director at Timber Development UK, here to talk about where we are at the moment with timber reuse. I think just a bit of background, really, where we are. Traditional construction model is very much around, based on a take, make, dispose model. What that results in, if you put that in a flow graph, flow diagram like this, is we end up with a lot of materials being produced, obviously production, installation, product use, repair, disposal. In that take make scenario, each one of those areas or processes create some amount of waste, And then based on the construction industry at the moment, we're looking at around C&D waste, so excluding excavation, around 49 million tonnes of waste being produced every year. Not much of that is reused in a closed loop scenario. It's sort of more of an open loop, sort of crushed concrete and stuff like that. Some of that is sort of reused or recycled on site. About 23 million tonnes ends up in what we call materials recovery facilities. Some goes direct to landfill, quite a small proportion. The remainder is sort of diverted from landfill, but a lot of that is sort of going into energy from waste. So up to 50% is going into energy recovery. A lot going into open loop recycling, so not closed loop, i.e. not going back to the manufacturer to be remanufactured in the same product. Is going into an open market. So there are obviously issues with quality and stuff like that can affect the recycling. Just on the timber side alone, we consume around 15 million cubic meters of timber in the construction sector. So around most of that is sort of softwood product. So you can see there it's about 8.5 million cubic meters of softwood. Also, and then you obviously got a lot of the panel board products like particle boards, OSBs, fiber boards, and MDFs, which are all manufactured from that softwood material, whether that's the byproducts or the thinnings or whatever it may be, tops of the trees, all go into those panel wood products. So the majority of our market is very much is softwood based. Small amount of hardwood, sawn hardwood, and some plywood, and again some engineered products, which again is from that softwood market. So there's quite a bit of timber going into the market each year, about 15 million cubic meters. Now, a lot of that, it's quite a complicated flow chart. This is from the industry's net zero roadmap. So if you want to have a look at that, look on the TDUK website and look for the timber industry's net zero roadmap. But you'll see there's a lot of interaction between different parts of the supply chain. So you've got softwood coming in the top screen there. That will be going into sawn product, but also into panel boards and stuff like that as well. So lots of interaction, lots of circular economy already in the material supply chain. So actually very little timber actually ends up going to landfill. A lot of the waste that's coming out the far end is going into biomass, and that's really where we want to try and see some changes. So if you sort of look at where that waste ends up, and this is from very much from the Wood Recyclers Association, and this diagram was from CEI Bois, which is the European Timber Federation. Got around sort of let's say 4.5 million cubic meters of wood waste. Sorry, that should be tons. 4.5 million tons of wood waste generated, not cubic meters. It's about 10 or 11,000 million cubic meters being generated each year. Not much going into maintenance. We've got quite a bit going into landfill. Going into biomass with energy recovery. So this 67% up the top here. Around 8% going into animal bedding, so short life recycling, I suppose we could call that. But about 24% of that waste is going back into things like panel boards, so recycled content within panel boards, which can have a long life. So if you're using an OSB board for your floorboards, etc., that can last a long time. Well over 100 years if it's maintained. The bit we don't know is how much being reused or remanufactured. There's no data on that. We have starting to get some information on the co-product that's coming out the sawmills and into the paddleboard factories, but no firm data. We just know it's happening basically. So the bits we need to find out is what's going on for reuse and remanufacture, and that's where we need to start adopting the circular economy models. And many of you may have seen this Ellen MacArthur Foundation, what's affectionately known as the butterfly diagram, where we want to try and see as much material into those inner circles as possible. And timbers are not sort of one of the materials that sort of flits between the two cycles, biogenic and technical. It can be we can treat it as a technical material, i.e. we can maintain it, obviously, we can reuse it, we can refurbish it and remanufacture it, and we can recycle it. So we should be doing, obviously, maintaining it, reusing it, preferably before it goes into recycling. And it's really at that point it goes into the biogenic cycle, and starts to be sort of cascaded recycling. So it's in effect downcycled a lot of the time. And what we want to try and see is obviously some of that being reused at its highest value or manufactured into secondary products. So just a few examples of what some of the stuff that's happening in the industry, and I'm assuming these slides will be sent around at some point, and you can click on the some of the articles that go into a bit more detail on this in the bottom left there. But this is the ABBA arena. This has been designed to be demountable. So if you've been to this show, that whole building comes down and goes into 20-foot shipping containers. And can be shipped anywhere around the world. So it's about 1,650 CLT panels. So that can be rebuilt anywhere in the world. So it's absolutely designed for deconstruction and reassembly. Got things like the roundhouse, which is starting to use salvage timbers. So that all of those timbers on the outside of the cladding there are all railway sleepers. They're obviously non-hazardous ones from a certain timber that was used for that. But these all been reused, planed down, cleaned up, and used as the cladding material to give. And this was actually an old railway building, hence why they use railway sleepers to try and fit in with the existing or previous use of the building. As far as timber can also be used to assist in the reuse of existing structures. So because timber is a lightweight material, we can actually add extensions either to the side or to the top of the buildings, and a lot of time we'll call these optopum extensions. Using a lightweight material, we can actually add more stories to the top of the building without additional excess loads on the foundations. So you don't need to put any more underpinning in, or may not need to adjust the structure to cope with that additional floors if you use timber. So this is an example of the old gramophone works in London, in Ladbroke Grove. And they added extended the existing 2-story RC frame to a 6-story building, adding around 60,000 square feet of commercial space. So that's the sort of thing we can do if we start using timber to extend the life of existing buildings as well. Obviously, we've got short life products. You've got things like pallets, which generally only stay in the supply chain for around 3 or 4 months. We manufacture around 20 million single-use pallets for the construction sector each year, just in the UK, and that doesn't include the ones that are coming in with materials from overseas. So the pallet loop is a circular economy reuse scheme that aims to reduce the use of single-use pallets, currently supplying people like British Gypsum, Isover, Superglass and Wienerberger. They've shipped over 1 million pallets to date, and we'll probably supply around 10% of the pallets in the construction market this year. And what that can do, it can repurpose around, for every 100,000 loop pallets, you can repurpose around 2,000 cubic meters of timber. It's equivalent to around 7,000 trees. It saves around 130 tons of CO2, they believe, and save around £800,000 in waste disposal costs. And also, obviously, if the pallets are returned in good condition, you can also then get around 400,000 back in a return incentive called their loop back payment. So there's some real options there for reuse already out in the market. So the challenges. So I think there's reluctance in the industry to adopt new ways of working. For example, manufacturers not using things like pallet loop or setting up take-back schemes to take back reused materials. Designers are generally not designed for reuse at the moment. We need to make sure that happens, and obviously that means making sure you've got the correct detail and installation of timber components to reduce, increase service life. So that's something we need to do, is try to use different new components to make sure we can reuse these products. Make sure we've got the correct detail and installation of the timber components themselves to make sure that service life is extended. Metal removal from existing timbers, such as nails, screws, connectors, etc., is a bit of a challenge at the moment for that. And there's no standard at the moment for structural grading of reused timber. We have EU grading systems for grading new timber, but there's nothing there to regrade that structural timber for reuse. So just a little plug from TD UK. We have just posted a new publication called Introduction to Timber and the Circular Economy, which goes through a lot of these challenges and what we might be able to do in this. So this is available on the TD UK website now. And really just a final slide for me, bit of call to action is, start to consider circular economy as part of our business as usual. We shouldn't be treating this as a bolt-on. It needs to be built in from the start. Look to implement circular economy business models, things like take-back scheme arrangements, etc. Ensure construction components are designed for flexibility, disassembly, and reuse. That's key. So that's very much make sure the designer is on board with that. Ensure correct detailing of timber components to ensure that surface life is met. So, detailing is key when it comes to timber. It's a natural product, but we need to make sure we look after it. And work with the timber in itself to insist on, on standards for the structural grading of reused timbers. So that's enough for me. My details will be on the slides when they're sent around. I'll hand back to you, Debbie.
Thanks very much, Charlie. Yeah, really interesting introduction. Thank you. I think perhaps maybe we can pick up in the Q&A a bit around the concept of the right wood going to the right place. I think not least the fact that we import a huge amount of wood that we could be using UK wood for. And I think that's part of the education piece as well, around people being used to using a certain type of wood, and therefore if it's not available in the UK, then we'll import it. But as you say, that kind of reliance on biomass, both in terms of not really sure where else it should go, so we'll just incinerate it, and equally they're quite hungry beasts as well, aren't they? So
yeah, absolutely.
Yeah. Interesting. Right, Phil, if we can ask you to share your slides now.
Great, have they come up? Good. Hopefully you can all see that. So hi everyone, my name's Phil Isaac. I'm a co-founder and director at SimpleWorks. We're a structural engineering company based in London. And I'm just going to talk to you briefly through a project that we did now actually 3 or 4 years ago actually. So it's been a bit of a while, but this sort of builds on some other research that's sort of been done in the industry and kind of carrying on. And that's around the idea of actually upcycling our waste timber. So Charlie's, I think, helpfully introed quite a lot of this, which is great, and sort of set up the kind of state of affairs currently. So in the UK, it's estimated we waste around 4.5 million tons in the construction industry of timber. We've all obviously kind of grown used to seeing scenes like this, and sadly not seeing too many scenes like this. But there are kind of great examples of sort of small projects, and I'm sure we're going to hear about a couple in a minute, of actually taking waste timber elements and being able to kind of upcycle them. So this is kind of a straightforward reuse, one-to-one, obviously in a slightly different kind of context, but I think the this isn't common, and I think it's estimated this kind of counts for something like around 2.5% of the timber that we waste in the UK in the construction industry kind of ends up in a happy home like this. The majority ends up like this. So why is this bad? Well, lots of the timber that we're taking out of our existing buildings has been there for a long time. So we've got all of that carbon from, decades or even centuries ago that's stored in our buildings at the moment. And what we're doing is releasing lots of that back into the atmosphere. So this is also kind of a sort of suboptimal situation, considering we're in a climate emergency today. So the current kind of sort of downward spiral that we're sort of probably all familiar with is that we sort of start with our solid wood, and then we're always downcycling. So every process that's done to timber effectively downcycles it. This is the current model. I'm sure we're all familiar with this, and therefore, I think Charlie already mentioned that one path for construction waste timber is to downcycle it into particle boards. That's also a better outcome than to sort of be burning that, but it's not necessarily the best use of the timber. So what we were interested in is whether actually we can, change the industry and look at, upcycling, actually adding value to the products. So this, I'm crediting Colin Rose, a researcher at UCL, for these slides. Colin did a project quite a few years ago now, I'm going to say probably around 10 years ago, of trying to create CLT from waste timber. So this project that we're looking at and going to talk about now is really building on that research, and trying to add value to the supply chain. So I think it's kind of quite an interesting project, but what I'm talking about ultimately is research and not yet full application. So our project kind of was kicked off in and around the kind of COVID years. So I think early 2020 we actually started this project. And it was funded by the Circuit Demonstrator, which is funded by the EU Horizon. So I'm going to sort of just, I guess, take you through the kind of chronology of the project and the different things that we sort of did to actually kind of produce glulam. Like I said, it was a research project, and so we learned quite a lot of lessons along the way, which we sort of shared in various publications. We didn't answer all the questions. The main question we were trying to tackle was more of a technical question rather than a kind of regulatory and insurance and all that sort of questions, which I think are legitimate and very important questions. But for now, I'm going to really focus on the technical stuff. So I'm going to try and signpost the main challenges. First challenge, procuring or even just getting donated waste timber was actually incredibly difficult. The current way in which demolition contractors set up is not to be hanging around, and storing materials. And this became a bit of a challenge for us to actually have to work with a contractor who's able to kind of keep hold of timber in particular long enough to be able to allow us to actually get hold of it. In the end, we worked with Cullinan, who are incredibly accommodating towards us. So I think a big shout out to them. The timber that we ended up using came from a raised access floor from a bingo hall in Elephant and Castle. So some niceties coming out of the Elephant and Castle development. And then lesson number 1 was just about procuring and storing the timber. Lesson number 2 was also that timber is classified as a waste material, a hazardous waste material, unless proven otherwise. So the other thing that we actually had to go through, and Keltbray did the legwork for, was having the timber tested and then dealing with the sort of waste transfer notices. So this is all kind of learnings for us as structural engineers, and ably supported by architecture friends at Grimshaw. So finally, we got hold of a load of timber. It looked a lot like this. And what we found was that generally lengths varied between about 0.5 meter and about 3 meters for longest pieces. And this was mainly because, from a demolition contractor's perspective, they want to cut it into short lengths so they can throw out a window into a skip. Long lengths are harder to handle. And so what we were finding is we had lots of short lengths. Now, generally, having had early conversations with Buckland Timber, who I'll get onto in a second, they were sort of suggesting that economically to make glulam, you need minimum of 1.5 meter length of timber. And that's really just because otherwise the finger jointing becomes uneconomical, and that's one of the main costs in making glulam. So there was an interest to us, though, in why this is quite good for glulam, because you can take shorter lengths. And they were sort of saying to us that on the continent, there's glulam manufacturers who will laminate shorter lengths down to around 0.5 meter. So I think that's definitely a kind of a tick in the box of upcycling towards glulam. So the process that we went through was to kind of do quite a rigorous categorization of the timber. Firstly, we sorted all the timber, and we circled and tried to identify all visible connections and metallic fastenings, that sort of thing. As sort of Charlie alluded to at the end of his presentation there, this is a major issue. The timber wasn't cleaned, even though they'd sort of made the demolition contractor had made their best go at sort of trying to remove fixings. But even just from this slide, everywhere you can kind of see a circle is where there's like either damage or a metal fastening. So the timber comes relatively damaged and not free of fastenings. So we kind of cleaned it up, removed fastenings on as much as we could on the left, just through a kind of visual inspection. And then we kind of went into a kind of process of taking lots of measurements of the timber to try and understand and build a kind of good picture of what we'd got. So that included a sort of rather lovely photo shoot for each piece of timber. The idea of this was that we'd be able to revisit later and look at like potential for visual grading of the timber. So every piece was photographed. We used non-destructive testing, sort of a dynamic acoustic method to estimate the Young's modulus for the timber, which correlated to the strength. And then, so once we'd sort of drawn up a good picture, I think we ended up with something like about 170 pieces of timber, unique lengths. We were fortunate enough to be working with Buckland Timber, who had sort of very graciously given us a kind of a good rate to manufacture these beams as kind of like a test case. So we sent all the timber off down to Devon, to Buckland, and they started running it through their planing machines to kind of just get it ready for laminating. And there were a few dings, and what they were finding is that despite our best efforts and various use of metal detectors, there were still metallic fastenings, and it almost threatened to derail the whole project. The finger jointing machines that they use are incredibly expensive, and a sort of a metal fastening or a nail or a screw running through one of those kind of had the potential to cause quite a lot of damage. So after purchasing an even stronger metal detector, we did manage to kind of get the project moving again. And the net outcome was the production of 6 glulam beams. So each was kind of manufactured to be representative size and followed a kind of 20:1 span to depth ratio for testing, which conforms to the codes. So I hope no one's totting up the mileage that the timber's now travelled, but off it went from Devon to Edinburgh. We were fortunate enough to get a lot of interest from Dan Ridley Ellis and Marlene in Edinburgh Napier University, and they very kindly volunteered that if the timber could be sent to them, they would happily test it, as they kind of have quite a lot of interest in this field. So yeah, off it was, delivered to Edinburgh, and then tested under just a sort of standard 4-point bending test, which is kind of common in structural applications. And generally it all performed pretty well. We were kind of happy, and failures were kind of as expected. Various other tests were done. I don't think I've got full slides. So we did various tests on the glue lines, and essentially a sort of full suite of tests that you would want to do from a structural perspective to kind of confirm the key properties. And then Q-graph, I think the thing that to us that was like most interesting was that whilst they were carrying out, prior to carrying out the destructive testing under the 4-point bending, Dan and Marlene used a more accurate form of dynamic testing to estimate the stiffness, the Young's modulus of the timber, which is directly correlated to the strength. And basically what we're finding is that the Young's modulus predicted from non-destructive methods using the dynamic system was actually quite closely correlated to the strength and stiffness that we were finding for the destructive methods. So why this is kind of quite a good finding, and we're quite pleased in general with this, is because if we were looking down the line at kind of pathways towards kind of commercialization of this, it sort of demonstrates that we could produce glulam of predictable strength and predictable stiffness. And I think that's kind of quite an important finding from this research, even though it's only on small scale. I think one of the issues with timber is you have to often test lots of samples to kind of get representative populations. So that's it. That's where we were a few years back. I know that Colin Rose in particular has kind of progressed his research in this area. So I think if anyone is interested, it's worth kind of looking up Colin and the work that he's doing. Yeah, and I think that's kind of where we're at. I think next steps for us, and the hope that we've had sort of since completing this, is that somebody might be interested in applying this on a project. So that's where we are. Thanks very much.
Thanks very much, Phil. Yeah, I think UK CLT, with its association with UCL, I think, as you say, is still moving it forward under Colin's supervision. So yeah, I think it's interesting. Do you know if anybody's actually using any of the CLT that's been produced in a project?
I think Colin had a demonstrator project actually back last summer, and I can't remember all the details, but I think there was I think actually, yeah, Charlie's got his hand up. He's going to tell me porter cabin, wasn't it?
Yeah, it was porter cabin. They're doing some demonstration projects for porter cabin.
Oh, the one that they moved around.
Yeah, so we actually had it at one of our events last year, and yeah, they're doing some good work. Where that is at the moment, I couldn't tell you. We're sort of actually just doing a research summary of Colin's work at the moment. So a colleague of mine's doing that at the moment. So we're going to be publishing that soon. So keep an eye out for that as well, because it's a good little project.
Fantastic. Yeah, we'll definitely flag that as part of our ASBP newsletter or something. So we'll, yeah, as a follow-up to this, that'll be really good. Thank you. Next up is Daniel, please.
Lovely. Let me just share my screen. Okay, perfect. So hi everyone, I'm Dan Bianchi, architect and partner at Cullinan Studio. I'm very pleased to be talking you through the Marlborough Sports Garden project today and using it as a case study for timber reuse to share some of the lessons that we've learned along our journey, which isn't complete yet. So we're about to hit RIBA stage 5. So I'm going to be focusing specifically on the successes and challenges up to stage 4 and procurement. And I'll have to come back and do a sequel when it is completed. So firstly, a brief introduction to the project to set the scene. The Marlborough Sports Garden is fantastically available public space, a few minutes walk from London Bridge Station, from Borough Market. And it's very necessary actually, because in the local area, there's a real lack of open space, both public and private. In the area, child obesity rates and poverty are among the higher rates in London. And this is where our client, the Bankside Open Spaces Trust, or BOSS for short, steps in. Here's what the site looks like now. It's a great open space in the heart of the city. BOSS currently maintains sports courts there and host activities like these. So there's netball courts, five-a-side AstroTurf, even a sand volleyball court, as you can see some kids making sandcastles there. And BOSS' vision for this site was to offer greater cross-section of the local community, opportunities to get involved, get active and get healthy. So they've commissioned this state-of-the-art mixed sports facility where young people especially can find it easier to eat well, exercise more, develop a love for sports, and just generally establish healthy habits for life. And the great thing from our point of view, and most people on this call, I assume, is that all of this project was really underpinned by circular economy and reuse principles from the outset. It wasn't something that we had to convince the client was worthwhile doing. So that was great. And here's the scheme we ended up with. So what we're doing is retaining a couple of these existing sports pitches. We're going to resurface others. We're adding a running track, excitingly, and also some other outdoor furniture. And what I'll be focusing on today is this new community building, which provides a couple of studio spaces, a cafe, an office, and just general storage, which is all ancillary, really, to the activity that's going on in the sports garden itself. And I'm going to zoom into this reclaimed Green Heart die-grid timber roof, the structure that's covering it all, which will provide shade in the summer. It gets pretty overbearing during the summer. Not only that, but also protection in the winter to this event space, which is between the two portions of the building. So that's what I'll be focusing this talk on. And it's at this point I really do need to name check our structural engineers, Ingenuity, who are local to the site, and they've been instrumental to this as anyone really. And here's one of their axonometric drawings, which explains the structure really clearly. But how do we come up with this finished design? So the journey really started getting hands-on with reclaimed timber. This is my photo of our engineer at the time when we went to Ashwell's Timber Yard in Essex. And it's sort of like going structural charity shopping. They have multiple different types of stock, and the staff there are kind of pointing out different types of hardwood, the typical lengths they usually get in, the workability of it. And it's from this research that we settled on the Green Heart timber. So Green Heart is particularly strong and stiff timber material, originally sourced from South America several years ago, often transported to the UK by boat. And at Ashwell's, they often receive old Green Heart timber, which has been used in marine applications like piers, which may have been there decades or hundreds of years. They cut it, sand it down, so it looks as good as new, like there on the right. But crucially, structurally, it also retains its integrity as well. And so it's from this research and these typical Green Heart elements that our whole design for the roof and indeed our whole grid for the whole building was based. So as is the key principle of reclaimed design, we're not designing and specifying a material to suit the design. This is the reverse of the traditional design process. We're effectively choosing a product, and this generates the design. So here it is, kind of a soffit plan of the roof. And that's how, researching these elements, that's how we knew that the grid shouldn't really be more than 7 meters in spacing, because that wasn't likely to be available. That's great. This works with internal spans we need on the building. We worked out that the depth should be about 350 mil, about half of those big lengths you saw in the photos. And we also developed a system which used several infill members to make good use of smaller offcuts or other offcuts or which were likely to be available in the yard. And my top tip and takeaway for this part of the process is just to get hands-on at the start. So the people that know design, such as architects, engineers like myself, we need to build relationships with the people that know the material and know the products. And then so we went from stage 3 to stage 4. This is a snip from one of the stage 4 drawings. So we've streamlined the grid even further, reducing the number of elements, obviously using less being one of the key circular economy principles. And it's at this stage 4, where we really felt the need to bed in and protect the use and the quality of the reclaimed timber as we go out to tender on the scheme, which is happening very shortly. And the project is a traditional contract, so the design team should have more control over the construction process than they might do typically on design and build. But even with the best will in the world, there are a lot of barriers to reuse and reclaim materials in the industry, which we just have to be realistic about protecting. And the rest of the presentation is some examples of how we're trying to do that. So this is when engineers like Ingenuity here have started labeling these stage 4 drawings with notes like these. So all steel and timber in the schedules to be sourced from reclaimed sections, and that end statement there. Contact design team to discuss alternative sizings and weights. So we accept that with reclaimed materials, we're not always sure what we're going to get or when we're going to get it. So by writing this in, we're just getting on the front foot about it and outlining the decision-making process clearly. And I mean, for the hardwood timber for this structure, it's a material that we're pretty certain about, but other elements in the scheme may not be, and we've got to be pragmatic about it and just be sure that we can look for other reclaimed materials as a first port of call. But if we can't do that, we've even included notes like this, so that if you can't get the grades of timber that are in the design or above, they've proposed alternative sizes and a lower strength grade, so the material can be sourced from other reclaimed stock or UK grown timber as well. And moving on to some of the detailed drawings, I think both Charlie and Phil both spoke about demountable kind of fixings. And just to draw your attention to a few things here, again, we've written that into the drawings, just a preference for future demountability on the project, using on this a minimal number of fixings, not only because it's efficient to use less, but also because green heart is so strong, it can be quite time consuming to cut and to work with. And just another tidbit specific to green heart, which our engineer Steve drew my attention to last week. Through their research, they discovered we have to really take note of the acidity in this material and mitigate the opportunity for corrosions on the fixings, which really shows like their commitment to understanding this material and really getting the best out of it for the client. And I think Charlie spoke about, really understanding the detail of timber. So that's, any work we put in now, I think will really reap the rewards when the building's gone up, obviously. And next, I just want to share what we've been doing on the specification side at stage 4, trying to protect the use of reclaimed timber. And I know the specification side is a bit more prosaic, part of the project process. And we personally found that there's still not that many precedents for reuse specification. So anyone on this call, do get in touch with good ones that you've seen. But one of the innovations we kind of came up with was this list to kind of determine how we would shortlist our suppliers. So we list each building element, any specifics around spec, and then we've listed in a preference order with numbers here and website links, good suppliers that we found. And then even beyond that, towards the right-hand side, tried to gauge the general availability any certification, and even the location, you know, how far away it is from our site on the Marlborough Sports Garden. And this isn't a polished document by any means, but it generated a lot of good ideas within the team, and this will help our conversations with the contractor, just to show them we're serious about this, and to give them a helping hand as well as much as possible. And I'm just going to give some more examples about how this is written into the final spec. Again, the credit goes to our engineers' ingenuity for this. So from the outset, the timber spec in the top table is just every element needs to be reclaimed, FSC reclaimed, that specific certification. And then below that, tying up what it said in that drawing I showed previously. If a particular element isn't available, you know, design team needs to be engaged to discuss alternatives to find a good solution. And then what about when the timber in our projects itself comes to be reused at the end of its project life? So we've thought about that as well, and included statements such as this: so no treatments or finishes should be applied to any timber element or component that will overly reduce its recycle or reuse potential, and connections should be designed to maximize the potential for future disassembly and reuse. And I guess, you know, someone trying to use the contract or the specs in a cynical way might say these statements are a bit unspecific, but our hope is that by penning these statements and referring to them during the tender interview process, we'll be able to gauge which contractors are really on board and understand the entirety of this process. And in my final wordy slide, sorry about that, I wanted to highlight that we've tried to make every effort to point someone who's not familiar with carrying out reuse of timber work, which, let's face it, not many people in the industry are. So we just want to point them in the right direction as much as possible by specifying, so look, you know, reclaimed or reused timber elements need to be inspected by a suitably qualified person. Sounds like common sense, but it needs to be stated in these things, and giving them help as well. So, you know, to grade the reclaimed tropical hardwood, you know, we suggest grading it according to this. If you want to grade reclaimed softwood timber, you know, it needs to be graded according to these BSs. And just back to a pretty picture to conclude. So I hope you appreciate me sharing some of the techniques that we're using to secure the use of reclaimed timber as we go into the latter stages of our project. It is due to go on site at the end of this year. So I'll have to give you an update, as I said earlier, when it is finally built, but would love to hear how you've been bedding these principles in on your projects as well. So do get in touch with me. And thanks very much for listening.
Thanks very much, Daniel. That was it was really interesting, and will be a really good case study that we'd love to have as part of our suite of reuse case studies on the ASBP website. I loved particularly you saying about choosing a product which then informs the design. I think you know, there's a few different conversations and examples around supply-led design rather than demand-led design, and you know, be it including your local quarry and your local forest, as well as your local buildings that are being deconstructed, or your local, you know, reused timber yard. But just really, you know, as a first part of the process, hopefully we're going to see more and more clients that are happy to do that from the beginning and work with their architect and say, you know, this is the brief of what we want, this is the location of where it's sitting, and can we just start off by doing a harvest map, and then that can, as you say, inform the design. Yeah, hopefully we will see more examples of that coming forward. And last but not least, Diana, if I can ask you to share your slides. You've got another great example of timber reuse happening at the moment.
Thank you. Let's hope this works. Let me see if you can see my slides.
Yeah, that's good. Thank you.
Yeah, fab. I can't see anybody, but I hope you can see this. Great. Thank you for inviting us today, and thank you to all the speakers. It's been a really good session seeing all the different examples. I'm Diana Waldron, and I work with Woodknowledge Wales, and today I'm here to present some of the learning from the Bontnewydd Sustainable School project, which is led by Gwynedd Council. So this project in particular was really blessed. It was in a really good position to actually identify that there were a few buildings that were due to be demolished, and the Welsh Government was offering a funding as part of the Sustainable Schools Challenge to help fund these type of projects. So they had these two schools, Ysgol Bontnewydd and Ysgol Glanadda in North Wales, where they stopped the demolition of this Victorian building to actually deconstruct it and use it as a donor of materials. And so they were in that privileged position that quite a few of the donor sites were nearby, and so they could put everything in place to reclaim these materials. So the motto of this project since the beginning was to bring back the buildings and the materials, bring them back to life. Similar to what Dan was talking about in his case study, that this one as well is a client, Gwynedd Council, that from the beginning they are the driving force of that motto, that they wanted to be a circular economy case study. So through this project, Gwynedd Council set out to create and develop a network of willing partners to bring this circular economy project to life. And they were successful in gaining funding from the Welsh Government as part of the Sustainable Schools Challenge. So these two schools came together then to become like the material banks or donor buildings. One of them was built in the 1970s, and one of them was built in the late 1800s. So it's a Victorian building. So the Victorian one was already vacant, so that the construction already started for that one. The one built in the 1970s, which is currently the site for the existing Bontnewydd School, that one is still being used. So they're waiting for these summer holidays to start the construction. And as you can imagine, there was very different type of construction from the 1970s as it was in the 1800s. So there's a lot of different challenges between these two different sites. And as previously mentioned, one of the problems with this type of salvaging material techniques is where are you going to store the materials, how are you going to transport them? So the community really came together to try to find solutions to all these different hurdles. So one local former school site was put forward to resolve the issue of material storage. However, one issue was still remaining, is that they didn't have a lot of protective storage for the timber pieces, especially that you want to protect from the elements. So they've just been going around as a community to come together to this goal that they have to preserve the life of the building materials, to build high quality schools, and to contribute to the circular economy of North Wales. So they want to use this case study as an example that it can be done, because it has been expressed by the client Gwynedd Council that it hasn't been easy because there's not an infrastructure to facilitate these. And as the previous case studies have demonstrated, you just have to get hands-on with the materials that you have, the resources, the human resources as well that you have, and people that are willing to move in the same direction. And I just wanted to have a quick mention about this organization, which had nothing to do with the expert team. It's called Menter Fachwend, and forgive my bad pronunciation in Welsh. But this is a charitable organization of the community that when they've learned about Bontnewydd project and what they were doing to be part of the circular economy, they were across the road to one of the sites where the materials are being stored, and they wanted to host us, and they prepare coffees and cakes. And what this charitable organization does, they support people with learning disabilities and vulnerable members of the communities to learn new skills. So this kind of projects goes above and beyond of it's just a building. It's more about the community and the people there, and how projects like this can communities together, and they have that sense of pride that they all contributed to. So the way we connected the Gwynedd Council connected with Woodknowledge Wales is that they realized then that they had these small gold mines of materials that they could reclaim, and a lot of it was a really good high quality structural timber, and they were trying to find the woody experts in Wales, and so that's how they contact us, and we're more than happy to help them. I'm going to skip through some of these slides because we're going to be sharing them and we don't have a lot of time left. But in particular, one of the projects that we had in parallel with this Bontnewydd School is the Regenerative Material First project that is focused on finding case studies where the designers actually focus first on what materials are available and then inform the design based on this, like what you were saying, Debbie, earlier on. So this project in particular gave us the opportunity within Woodknowledge Wales to focus a lot of our work as well in these principles of circular economy, to be a lot more hands-on as well, because in the previous years we've done a lot of work in the overall picture and how embodied carbon is an important part of this picture. But if we don't consider the reuse of material first, we're not starting at the right place. So this case study gave us the opportunity to put a lot of that research work that we did during the Homegrown Homes project. We published a free guidance that you can access with this QR code, and we were looking into the different river stages and where is the largest potential to have the most carbon reductions. And as we know, the early stages present the largest potential. And I wanted to link that with another consultant that Gwynedd Council brought on board for this project, Baker Brown. They were the circular economy consultants that helped us to develop a material reuse book for this particular case study. And they were talking about this adjustment of the river stages to close that loop, which has been mentioned by the other earlier speakers as well. And Baker Brown, they also came with us to visit the sites in North Wales, and they gave a really enlightening presentation to the community about the work and their experience in the circularity of materials and how to prioritize, how they call it, to mine the cities, use them as the bank of materials before we look into the natural environment. And thanks to all the work that Baker Brown did, as well as Frame 4, they were the ones that were doing a lot of the material audit before the deconstruction and afterwards. So they had an estimation based on what was available on the existing buildings. And then with that, they could gauge what was the percentage of damage. So in future projects, they can get closer to those predictions. And in this particular case study, these are the three largest sources of materials that could be reclaimed. So the slate tiles, the bricks, and the timber pieces as well. There was a lot of really good quality structural timber. So they did a really good job with the initial stage of the construction. These are all bricks, slates. And the timber was a lot more challenging. And as Phil and Dan mentioned earlier, the steel fastenings and nails and all of that are like the biggest enemies of refurbishing timber pieces. So we have been encountering a lot of issues. And they don't want to just use the timber in a different way. They want to do their best to reuse it structurally. So we have been going through the process of looking into regrading these. And so what we call the donor buildings and site locations were presenting a different range of challenges. And here I'm just mentioning a few of them. For example, the different types of bricks and mortar. The Victorian building was lime-based mortar, so it was a lot easier than the 1970s to reclaim these bricks. The one in the 1970s, they're going to be used as aggregate. They're going to have to be demolished. So these are things that can, teach us a lot of lessons on how are we building our buildings now, and how are we planning for the constructions of these buildings. And focus on the timber pieces. Some of the biggest challenges was, well, first of all, try to extract them from the building without breaking them and damaging them. And then once you successfully did that, how do you transport it to the storage place? A lot of these pieces will have all painting and elements and treatment. So identifying all of these issues so that you can identify the strength of these pieces are all big challenges. And again, the biggest enemy, metal fixings and nails. The 1970s has this opportunity to extract these beautiful pieces of glulam and also parquet flooring. Again, all of those opportunities come with a lot of challenges that they have been exploring on what's the best way to do that. The biggest challenge in this particular project is trying to protect the timber pieces from the elements once they were extracted from the building. And beyond that, the regrading can't really be done until they are in a protected storage. So we have done visual grading in advance, but the last absolute grading can only be done once the pieces are protected. And all of that entails a lot of issues with warranties, insurance, and many other things. But of course, we like challenges and we like searching for solutions. So we've been quite a few times to the different sites. We have had several meetings with the design team of Bontnewydd, with Gwynedd Council, trying to bring together experts that can advise on the different topics. We had the opportunity of visiting a pre-deconstruction. And for example, this is a piece that after post-deconstruction, this is what it looked like. Similarly, this beautiful Victorian hall, they managed to extract these timber trusses, and this is what they were after they came out. Sadly, we lost these beautiful windows. It was too complex to extract them successfully. So I'm not gonna have time to go into all the details, but when we share the slides, you'll see that we put together group different members of the expert teams from different areas to give them advice on potential ways to, if there was a chance to reuse, for example, the foundation concrete slab. And if that wasn't an option, could they look into concrete-free foundation scenarios into suspended timber flooring? And this a shout out to all the experts that contributed to all these conversations. So Jay Cottrell from PH15 was sharing examples of when she was using suspended timber flooring. And Beth Williams from Momentum Engineering, she was sharing examples of concrete-free foundations. And this was one of the diagrams when we were having a conversation of where the existing building footprint is and where the new footprint will be, and whether it was possible to reuse the foundation slab. And even if all the solutions would not be suitable to be implemented, at least exploring them is what's valuable. Also within Woodknowledge Wales and collaborators, a shout out to Phil Dines and John Sweeney as well. They came with their expertise. They have a lot of experience in wood science, grading, and they were providing their advice on the type of the characteristics of the timber from the reclaimed timber, and also the regrading potential. They did some microscopic investigation of the samples of the timber that was reclaimed, and it all felt very much like detective work. All the dialogue about what are the characteristics that they're finding about this timber and how what's the strength potential, and where is the original and of this timber. All of this is really important to assess its suitability to be used again as structural timber. And this is the proposed new design for the Bontnewydd School. But again, as part of the learning, we learned, it's highlighted that time pressure is the enemy of efficient design and cost savings. A lot of the time, the building design comes before the material audit. Again, it was mentioned earlier. Ideally, you want to do it the other way around. You want to see what availables and what infrastructure you have around you, and then design your building with that in mind. So some of the key learnings, I'm not going to go through all of them. You can have a look at that later. But yeah, some of the highlights are that sometimes the energy inputs can negate the apparently benign process of recycling timber. So planning is key. So, for example, we also had a conversation with Buckland Timber about the potential of using the salvage timber to create glulam. And they were sharing that experience with us, that sometimes all the metal fixings and everything will make it so time demanding, and you have the risk of breaking equipment in the sawmill. So sometimes that negates the benefits. And as much as possible, do the material audits first and then the design second. And so one item that we felt it would have been great to explore in a lot more depth is saving the slab that will be, because they're going to be using the same site, and an existing slab is going to be dug out to then put some more concrete in there. So if they had more time, they were going to, they could have explored in more detail on how to reuse existing slab, which is viable. And it's it will represent a lot of cost saving as well as embodied carbon savings. And yeah, I'll let you have a look at that in your own time when we share the slides. But there's a lot of topics in this area, and the Bontnewydd School was a fantastic example of how if you have a client that is willing and brings that community together to make it happen, it is possible. So if you want to know more about this case study, please feel free to get in touch. And yeah, in Woodknowledge Wales, we go beyond wood, beyond knowledge, and beyond Wales. So don't hesitate to get in touch if you want to work in any area related to sustainability. Thank you.
Thanks very much, Diana. Yeah, another fascinating example. And again, as you say, very much one also of taking what you've already got and trying to make best use of it before sourcing virgin materials. And again, bringing up the point of that warranty and insurance, that's definitely something that needs to have a bit more work done on it. And I guess also looking at the successes around the reuse of structural steel, the successes around raised access flooring. It's a much more known material. When you're starting to reuse bio-based materials, there's so much more breadth of what if and the different parameters, which we've already briefly mentioned around standards and some of the work that's happening there. Okay, so we just have a bit of a look through some of the questions. We've had a couple of them upvoted, so I'll just go to those first. I don't know if, oops, I'm going all over the place at the moment, whether the question around Ingenuity to Daniel from anonymous attendee. How did Ingenuity do the strength grading of the timber for the sports garden?
How did they do it? It says in the specification which guidance they're referring to, and I know Charlie mentioned that there's no standard for structural grading of reused timber, but they do strength testing on site at the yard that we went to, because they got a workshop there as well. That's at Ashwells. So we kind of worked with that grading as the standard, and then it's just taking the existing ones which are for non-reclaimed materials. I'm sure Ingenuity could go into a bit more detail than me on that.
Thank you. And also another one that's been voted as well. I don't know if Seb, you want to come off mic. Larry, can you get Seb to come off mic, or if I just ask it myself? I don't know if he's there.
Hi,
Seb,
Debbie. Can you hear me?
Oh, there we go. Yes.
Yeah, thanks, Daniel, for the presentation. I really liked that you had a clause which was asking for contractors to provide EPDs of the products that are being provided. What was your vision as to how that would be addressed for those reused elements, envisaging that there probably aren't EPDs for the reused bits of wood in the yards?
That's a really good question, and one I think about in terms of, when how do you assess the embodied carbon of a reclaimed bit of green heart, which may have come over from South America on a boat from the colonies about 200 years ago. Where do you kind of start giving it certification from? I mean, as I said, with a lot of it, there's no hard and fast legislation to point to at this point. We're just trying to be an openness and transparent with, from both parties, from designer and contractor, trying to get that. And so, the reclamation yards with things that, like, such as timber, they'll give you a certain level of information to come with that, the strength grading that they do on the site, which I just spoke about. There'll be paperwork that comes with that. Is it actually called an EPD? I'm not entirely sure it is, but just trying to evidence that we are providing a certain amount of quality or sourcing assurance, I guess is a better word, from those materials. But that is a good question.
And our last one for Daniel before we let you move on to somebody else. On the cost side, did the use of recycled timber make the project more costly as a result?
So I don't know if others have experienced this, but we've found generally that the cost comparison between virgin material and reclaimed is often about neutral. With this timber, it is a bit more of an unusual element. So I think it will, it may be more expensive, but we basically not justified because the client was inclined to use a natural material because it's befitting with their ethos, befitting with the healthy lifestyle and living that they're trying to promote on the sports garden. But by being really assured and streamlined in our design, by saying you can get them in these sizes and we're using minimal waste, and we were able to assure that it had been properly costed and properly thought about with the product in mind, and we designed the structure to be efficient rather than just doing a design and then chucking whatever material needed to be onto it. So that's how we got around that initially. But what I will say, the cost of storing the timber is becoming our next query as we come to go to site. So this is an existing site which is in use now. There's probably children on their school lunch break there right now. We're trying to keep as much of it open as we can as we build. So where are we going to, once the timber comes in stock, potentially at Ashwells or wherever we source it, the cost of storing it in a yard may be more expensive, but we don't have room on site. So our client has got all connections in the local area. He's asking developers who've got land near the Marlborough Sports Garden, if you're not developing your site for a year, can we store our timber there for a year, for a few months or so? So the transportation costs are something to bear in mind, as well as the upfront cost of the material and working it.
And I think as well, because it's all very nascent and the infrastructure's all quite new, I think, exactly what you're talking about, sort of meanwhile sites, and hopefully as these become more commonplace, that infrastructure and those questions will be clearer, and you'll know how much the cost is, and be able to better estimate and justify the differences, because of course it's easy to say, but it isn't just the financial cost, it's the carbon cost, and it's ensuring that we obviously bring in the full cost of one solution against the next.
Just to say that I see that Flynn, who's worked with us on the scheme, has posted about one of the previous questions. So yeah, he's more informed than me. Ashwells don't do the proper strength grading; they do their own tests, but they've worked with Phil O'Leary to work it out. Thanks for the correction, Flynn.
Thank you. So David Randall, I don't know if you want to ask your question about take back. If you're there.
Unmute. Am I unmuted? Hello.
Yes. Hi.
Yes. So the take back scheme sounds very, important if you're designing for sustainability and reuse. So if you started sort of ab initio with sort of project, who can you approach to assist you with a take back scheme to look after the transport and the regrading and everything if you don't have the capacity to do it yourself?
Are you saying in terms of, because
Well,
you haven't got a client that wants to take it, but you want to not have it incinerated or landfilled.
So I guess I'm saying reuse hubs for timber take back. Could they be extended? I mean, I noticed somebody asked an interesting question about it was Catherine Adams just now. Who's the best place to do this? Is it in the timber world? Is it reclamation yards, timber suppliers? I mean, who could do the take back as a kind of joint venture?
Charlie's got his hand up. Away you go.
Yeah, I
Thanks,
thought I'd get this one, Debbie. When we talk about take back, what we're really talking about there, David, is around the materials manufacturers or product manufacturers actually offering a take back service. So that's really where we're coming from with that. So I know in your questions you sort of mentioned temporary buildings. So for example, people like Porter Cabin we mentioned earlier on will take back their temporary buildings, refurbish them, and send them back out, for example. So that's where we're sort of talking about a take back scheme as a manufacturer. Another, there are others out there that are looking at this for different materials, but not necessarily timber at the moment. And I think we need to try and make sure that some of the timber product manufacturers start to set themselves up on that. So that's really where I was coming from, take back on that point. I'm not sure that answers totally your question, because obviously the issue is when we've got older buildings that obviously need timber removed, that I think we need to, I think it's really going to be entrepreneurs that set themselves up to take that timber back, store it, do something with it, and market it as a product. But I think they need some help in, going back to what we're saying around standards, and Daniel saying that, the standards aren't there for grading that timber to a strength grade at the moment. And it's a lot, you can do it. It's not saying it's impossible, but you end up having the engineer having to take a lot of that responsibility to say that bit of timber will do the job that he thinks he's put it in place to do. So there's a lot of responsibility on that engineer. Really, what we need is some standard guidance that they can work to, is what we're pushing for on that side of things. And once we've got that, I think that will open up some of the markets. You've already got people like at one of our sponsors day, Cleveland Steel and Tube, which are actually starting to do that from a steel point of view. We want to see that happening from a timber point of view going forward as well.
Thank you, Charlie.
Thanks, Charlie. And Sarah's also put in as well into the chat around the work that Salvo's doing, obviously with their network of salvage yards. And she said that also Salvo supports with reclaim testing, developing reclaimed product declarations, which sit at a deeper level to the truly reclaimed standard. So there's definitely different work that's already happening around this, and I think this is another example of how the industry isn't so good at joining those dots. And I think people coming into sort of circular economy and into reuse with kind of lots of interest but not much experience, they're quite often blind to where they can go to find all this information. So hopefully webinars like this and the information that TDUK put out and Woodknowledge Wales as well can help support people to do that. Okay, where's my other questions gone? There was another one for you, Charlie, I think. There. How can existing supply chains be adapted for retrofit? Ooh, you could probably talk all day on that.
Yeah, not sure I understand the question here. I think as far as supply chains, if we talk about retrofitting of existing buildings, in places like Gramophone Works, I think for me, we need some policy change there rather than supply chain intervention as such, because the supply chain will follow the policy change. And I think what we need is this, where we very much talk about embodied carbon targets and assessments for new builds. And that would really assist in making sure as much material as possible is reclaimed or reused in its original form. Because if you've got an existing building that you refurbish or retrofit, you've already lowered your carbon footprint because you've not got a new frame going up, for example. So for me, there's some policy change that needs to happen around that. I think we also need to see changes around the VAT associated with that as well, because at the moment there's no VAT on new build, but there is VAT on retrofit, and which sort of dissuades clients from actually doing, sometimes will dissuade clients from doing a retrofit project because obviously you've got to pay VAT and it's going to cost them a lot more. So so it's sometimes cheaper to knock it down and start again, which doesn't really suit the circular economy that we're trying to promote. So I think those are the two big changes I think I'd like to see and the supply chains will adapt to that.
Thank you. And just as well, I think you've kind of answered it by putting your the link to the latest guidance on assessing timber for hazardous waste treatments there in the chat, because one of the questions was how are you dealing with determining testing wood which might have potentially hazardous treatments, given the regs have changed, well, for the better. Have they changed since 20? They changed.
They have now, yeah. That's the latest guidance which came up in 2024. There was a lot of testing. This project started back in 2017, if I remember rightly. Well, 2017, early 2018, if I remember rightly, with the Environment Agency and the other regulatory agencies around the UK, and the NFDC and the Wood Recyclers Association all came together to sort of do a big testing project on waste timber. In the interim, the EA sort of deemed timber as potentially hazardous, so mainly structural timber. So your normal roofing timbers, floor joists, that sort of thing that would be in a structural application that were installed after basically post-war, so from 1950 onwards, would be deemed as potentially hazardous, and that was the case for a few years until we've done a load of testing. But it was finally agreed just before Christmas last year, so the end of 2024. That was no longer the case. The testing had proved that those structural elements, although they were treated with a hazardous chemical, the concentration of those chemicals in that timber wasn't enough to deem the timber itself hazardous. So they are now, all those structural elements now are all deemed as treated non-hazardous in the latest guidance. The only ones you really need to still worry about is anything that's been treated with creosote, for example. So that might be things like railway sleepers, telegraph poles, which always were hazardous and still remain hazardous, things like that. So if you go to that link that I'll put in the chat, that you can download that guidance, all free to download, and that runs through all the different possible timber products you might come across, and the vast majority of them are now classed as non-hazardous. It's only really those industrial products, from industrial sites or railway sleepers, telegraph poles, that sort of thing, that are now classed as hazardous.
Thanks, Charlie. Couple of questions for Diana. What mortar will be used on the new building? Will it be lime or cement?
Yes. So that's a really good question, because the reclaimed bricks, they're Victorian. If it's cement based, this has the potential of damaging the Victorian bricks. So it will be lime based mortar.
Thank you. And you pointed when you regrade the donor timber, what allowance did you make for previous loading and timber age? And you've battered that one across to Phil O'Leary that's on the call.
Because we're very lucky he's here, yes.
I don't know if Phil's able to unmute, please, Larry. If you can just have a quick chat around strength grading of old timbers. If you're still there, Phil. Yeah. Or is he dipped out thinking he might get asked? Yes, brilliant. Yeah. Thanks, Phil.
Okay. Yeah, that's always a challenge, and one of the advantages, one of the main challenges of regrading old timbers is not knowing where they've been used. But if we know where they've been used, we can take that into consideration. And as Charlie was alluding to, there isn't a standard, and looking at standards for grading timber when we don't know how it's being used. But when we do know when it's being used, we can make allowances. So there's a big difference between not knowing where the source is and what the source is.
Thank you. And I think that also kind of harks back to the materials passports piece. We've got kind of two sides of the coin, really, that we're dealing with in the construction industry. It's ensuring that what we build now is going to be disassemblable and reusable in future generations, but then obviously also looking at what we've got existing and how we can best make use of that. And materials passports can obviously either be generated from when a product is first manufactured, or as a material is coming out of a building. If we do know enough information about the provenance of that product, then we can obviously assign a material passport to it then, so that when it's reused, hopefully it might actually be reused as a third life, but it then will have its material passport attached to it to make this process so much easier, hopefully in the future.
Yeah.
Catherine, do you want to come off mute to ask about the EPD question? If you're still there.
Oh, hello. Hi. Yes. Hi, everyone. Sorry, I missed the beginning of the webinar, but I'll listen back. Yes, question. Sorry, I just remember now. Yeah, it was just about, in the reuse world, I think we're starting to see a few products, not that many, being advertised as, the most lowest carbon product possible. Maybe there's a bit of a price premium that goes along with that, but that's a different conversation. I just wondered how would work for timber, and do sort of the whole life carbon EPDs help or hinder that argument?
Can I have a go at that one if you want, Debbie?
Yeah, thanks, Charlie.
Thanks, Catherine. Yeah, I think the key thing here is going to be transport. If you have to move that timber a long distance, and I think, I know Phil's was a totally different example because it was a test project. It was going all the way around the country, but generally these products you generally keep fairly local. So if you can take it out the building, store it somewhere fairly local, minimal processing of that product, and put it back into the building, the actual carbon associated with that is going to be very, very low, and much lower than a virgin timber product, because virgin timber products generally, obviously you've got to fell the tree, you've got to move it to a sawmill, that sawmill's got to then kiln dry it, that's where a lot of heat goes in, and then transport it down, generally from somewhere in Scotland down to, more likely somewhere in the southern part of England is where most of the materials are used. So you're transporting that material a long distance. So as long as you can keep that material fairly local and do minimal processing to it, yeah, absolutely the carbon footprint story will add up. No problem at all.
Anybody else want to add anything to that? You're good. Last couple of questions then. One from Ian. I don't know if you want to come off mute. Talking about different ways of working with reclaimed timber.
Hello, everybody. Just a thought that when we're thinking to do something different, then that needs to go right through the whole product chain. And I used the example of glulam with finger jointing. Well, if your recycled timber has got a lot of metal in it, do we need to have the finger joint? Is there an alternate joint that could be used within the glulam process? Now, I don't know anything about glulams particularly, but that's an example.
I think as well, I'm sure that I've seen some wood nails that can go into a nail gun as well.
I was about to jump in there and say we did another sort of a follow-up EU circuit demonstrator project that actually looked at sort of timber floor cassettes, if we can make them from without any metallic fixings, and we looked at these. I can't remember the name, sorry, but yeah, the timber nails that go into a nail gun, they kind of just get fired in, so they're quite good. And there's also research in like Dowlam, Lignalock. Thanks, Seb.
Lignalock, that's the one.
Yeah, and yeah, Dowlam is also a product. I think Ian, in your question, wrote in. That's also something sort of people have looked into a little bit, mainly with new timber, but yeah.
Yeah, I think that's where we're coming from. That's where we're looking at new timber systems. I think we need to look at how we might be able to fix them without, with timber nails, for example, so that you don't have this issue at the end of life. But I think where we obviously have got the issue now, the key thing is you have to regularise that timber to a size. It does need to go through some sort of planing machine at some point. And that doesn't like nails either, so it's not just the finger joints. So I think the key bit is obviously technology to actually extract those nails. And I know talking to Colin, I think the last time I spoke to him, they was actually looking at robotics and stuff like that over in the States. They was looking at something over there that, along with AI, that would be able to, and metal detectors, I'm assuming, would be able to find the nails in there and actually extract it robotically. So you haven't got that human intervention that might miss it. It would all be done electronically. So those are sorts of process changes that may happen. And when it comes to, we can go back to the carbon story, that's still a lot better than maybe going and getting a tree out of the forest, because you're going to use a lot less energy doing that and getting it to a regular size than you would getting a new tree out of the forest, bring it to a sawmill in it, etc., to the regularized size. So there are definitely advantages of using that reclay timber if we can set the production facilities up close to where it's going to be used. That's the key at the moment.
And I think a good, thanks, Charlie. I think a good last question in the remaining few minutes, so keep your responses short, is from Thomas Heslenberg. I'll just ask it, Thomas, if that's okay for speed. Based on your experience of the respective presented projects, what is the one thing which you believe would have made your projects more straightforward? So I guess yours is just more of an industry, if you could wave your magic wand, Charlie, and the others are looking at their specific projects. Do you want to start, Charlie, since you're off mic?
Yeah, one thing that would make reuse of timber more straightforward, I think very much is the standards for strength grading of reused timber. I think we definitely need something along the lines of that. That would be my magic wand moment if we could get that standard in place. That assist and make engineers a lot more comfortable about reusing reclaimed timber.
Thank you. Daniel's next on my screen.
Yeah, for me, it would be, I know they're starting now, but more digitization of these material banks, yards, so that we're not doing so many individual phone calls up. Have you got this in stock? Have you got that? What's this? Like a centralized place. And that's not being lazy. I love to get out and see these things, but it's just a practicality of the job. And making that a digital process would be great for designers.
Thank you. Phil?
Mine actually sort of builds on Daniel's point. Actually, it's about sort of reliable supply chains. I think the biggest challenge we found was just sourcing reclaimed timber from demolition and deconstruction contractors. So again, that sort of, I think, ties in together.
Thank you. Last but not least, Diana.
From our perspective, suitable infrastructure. We found that every time we needed to overcome the obstacle of how do we transport, how do we store, how do we process the timber pieces, there was always a block. So more an infrastructure that has a lot more enabling elements to allow projects to reuse materials.
Thank you. And literally 13:59 on my screen there. So that's fantastic. Thank you very much again to our 4 presenters. Very much appreciate you spending the time with us this lunchtime to present for this ASBP webinar. We will be sharing the recording and the slides in the next week or two when Larry does his magic behind the scenes. And yes, hope you all have a really fantastic summer, and take a look at the ASBP website and the content on there, and hopefully we'll see you at an event in the autumn.